Welcome back. Today is day 7 of our Introduction to Circles unit. We will be investigating the relationship of the angles in an inscribed quadrilateral. We will be using GeoGebra again and then concluding with a flowchart proof. Hope you enjoyed the video. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Alright, so what's so special about an inscribed quadrilateral? So that's your task right now. So let's go ahead and build one. So again, if I want to build a quadrilateral, I can easily place 4 points along the circumference of the circle. So it doesn't matter where I place them, that'll be fine. And now I just use the point to do that. So now let's use the segment tool. So the segment tool to connect these to make my quadrilateral. So I'll connect C to D. I will connect D to E, so there's segment DE, there's segment EF, and there is segment CF. Okay, so now I have a quadrilateral, and if you did a good job of this, then when you move these points, your quadrilateral should stick to the circumference of the circle. So there we go, perfect so far. Alright, so now what is so special about this quadrilateral? Well, the next thing it asked us to do was to find the measure of each angle. So let's use the measure tool. So this measure tool will find the measure of this angle. So I'm going to click on two sides. So I'll click on this side and this side. Perfect. So this measure of this angle is 78 degrees. Let's do the next one. And the next one. Perfect. Let's do these ones. Good. And these ones. Perfect. Alright, so now when I have my students do this, when they're doing this problem, the first thing they may notice is they might get their calculator out and they'll notice that these add up to 360 degrees. So no matter what they do here, they'll be like, okay, I noticed that these three add up to 360, but after that, we usually don't find anything else. Usually they have trouble finding something else. So one thing I like to do is just ask, what happens when we move one of our points? So really pay attention to now what happens when I move just one of my points. So let's take point E here. So if I move point E, what happens? Well, first thing I notice is that the measure of this angle here, E, is not changing at all. So first thing I notice is, well, that's not changing. But I do also notice that this angle F and this angle D, those are changing. But also if you look at C, if you take a look over here at angle C, let's take a look at that one. That one did not change at all either. So we have two angles that are staying exactly the same, and then two angles are changing. So now, what if we take another look? What if does that only work with the E, or does it work with other ones? So let's move F. So when I move F around, what do you notice is happening? Well, now something else is different now. So now this time, the angle that I'm moving is F, but it's not changing, and either is the one across from it, the angle D. But the ones on the left and the right, those are changing. So I notice that. And if I do the same thing, we'll kind of get to that pattern. And we're like, okay, perfect. But now let's get to the point where we're like, okay, so now after we've done that for a little bit, then I want to take a look. Let's take a look at those. Now let's focus on the angles that are changing. So the ones that do change. So if I move point E, we know D and F will change, but is there anything interesting about those? And maybe I'll stop at certain places for them. So like, let's take a closer look at angle D and angle F right now. Well, this one says 100, this one says 80. Okay, that's cool. Let's stop over here. Let's move at like 10 more degrees. Well, this is 110, this is 70, and usually right about now, people will start understanding, oh, I see what's so special. Let's go 10 more degrees. So we have 120, and this is 60, and by now you should see like, oh, what I'm noticing is the opposite angles are always adding up to 180. So 120 plus 160 is 180. And does that work the other way around too? Well, what's 94 plus 86? Well, those are going to add up to 180 also. So that's what we did here. We're trying to see that relationship between when we put a quadrilateral on a circle. So when we inscribe a quadrilateral, we are noticing that the angles that are across from each other, we're always going to add up to 180. All right, good job. So now guess what? Your job is going to be go ahead and prove that. Prove what we just figured out from GeoGebra. So what we're going to need here is we're going to need to draw a quadrilateral. So I'm going to draw a quadrilateral. How about this one right here? So let's connect these segments. And let's give this a name. Let's name this quadrilateral. How about A, B, C, and D? Perfect. All right, so now that we have that, what we're going to try to show today, let's call this A, let's call this B, let's call this C, and let's call this D. So we're trying to show right now that the opposite angles will add up to 180. So that's what we're trying to show. So we need to show actually two things. So first, let's do A plus C is equal to 180. So that's the first thing we're going to try to show. We're going to try to show that those two angles will add up to 180. And we're also going to try to show that B plus D is equal to 180. Perfect. Okay, so we're going to try to do that. This will follow the same kind of pattern that we did last time, but since in this problem, let's try to use these ones first. So we're going to try to prove this one first, this pair. We're going to have to do this twice, but we're going to just do it once and then you can do the second one on your own. So let's try to prove that A plus C equals 180. So the first thing we notice, very similar to our last proof, is we notice that angle A is an inscribed angle. So that's the first thing we notice. And remember, we always have a statement and a reason, and we know that because it's just given to us. So that is just given to us in the diagram that we have there. So again, I'm going to be using a flowchart proof on this one because I like those. Those are very nice and they look nice. It helps me organize my thoughts and see what I'm doing. So I know A is an inscribed angle, and I also know angle C is an inscribed angle. Since I have room, I can write it all out. Inscribed angle, and that's also given to us. So I have a statement and a reason, so that's also given to us. If you do a flowchart proof like this, you can turn this into a 2-column proof really quickly. All right, so there we go. So now we know angle A is an inscribed angle. We know angle C is an inscribed angle. And now we can make some inferences, so that can tell us something. So now what that tells me in this problem, since this is an inscribed angle, this angle measure here will be half of this arc measure here. So we're going from point to point. So from this point to this point, it'll be half of that. So we can write, so if this is A, then we can conclude that this arc measure will be 2A, or just double it. All right, so let's write that in. So we're going to say in this problem, the measure of arc, what arc? BCD is equal to 2 times A. We're just doubling whatever angle that we had there. And so then the reason is going to be inscribed angle theorem. So that's the theorem that we're going to be using for this one. Oh, I should have did that in blue. Let me erase that because it does look much nicer on. Okay, so let's try that one more time. So inscribed angle theorem. All right, so, and we always have a statement and a reason. Statement and a reason. There's the first one. Now we can use the same kind of logic and come up with the next statement. So in this next part here, we notice that, well, angle C is an inscribed angle. So let's use this one. So here's angle C, and the measure of this angle is c degrees, so that means that this arc is going to be twice as big as that angle, so this arc should be 2 times c. So we can write that in. This is just 2c. And now I can continue on. So we know the measure of arc. Oh, I like when I actually spell something bad. So the bad arc, so the measure of bad arc is 2c, and we know that because this is also an inscribed angle. So inscribed angle theorem. And just like we did with the other problem, just like our inscribed star, now we should see a relationship happening here. So we should notice that the green arc and that pink arc is going to complete a whole circle. So then we can write a statement that combines these two, where these two get combined now. So now we're going to say 2a plus 2c is equal to 360, because that's the measure of a whole circle. And our reason for this is going to be definition of a circle. That would be sufficient. Or you could say, if you wanted to write it out, if you're doing like a paragraph proof, all circles will equal 360, something like that. All right, and now we're going to use a little bit of algebra, and I'm running out of room, so we're going to use, remember we see a 2 in both parts there, a 2a and a 2c, so I'm going to use distributive property to leave me with a plus c equals 360, and that property is called the distributive property. So now we have, guess what? Now we're very close to finishing this up, and one more step. If we divide both sides of our equation by 2, I'm going to write it in here, but usually we don't. If we divide both sides of my equation by 2, what will happen? This will leave us with a plus c is equal to 180 degrees. And the mathematical rule is our division property of equality. So remember, whatever you do to one side, you have to do the other side. Remember that little rule your teacher told you a million times? That's it. We're going to use it. And now guess what? We have done the first part. We have proven a plus c is equal to 180. So we have that. We're done. So we know that those two angles add up to 180. And you would do the same thing in the next proof, but now we'll use b and d. So we'll do the next part, and then we've proven both of those. All right, so hopefully you see what's going on here. Now what we know is in any inscribed quadrilateral that the opposite angles will always add 20. Doesn't matter, as long as the quadrilateral is inscribed on a circle like it is right now, no matter what happens, it'll always add 20, the opposite angles. All right, thank you, and hope you enjoyed. Should be just a slam dunk now. Now that we completed our proof. So it says find the measure of the arc indicated. So what we're trying to figure out is we want to figure out what's the measure of this arc right here. So what is the measure of this? Of this angle? Well, what do you see here? I see a quadrilateral, and I see the opposite angles are listed here. So I see one angle here, and I see this other angle here. And what conclusion can we make about these two angles here? Well, since they're opposite each other, we know that what? We know that they have to add up to 180. So something plus something else has to equal 180 degrees. And we already know one angle is 74. So now we just got to figure out what the other one is. So what is this angle going to be? What's the missing one going to be? Well, we can do that really quick so you can kind of see mentally that it's just whatever 180 subtract 74 would be. That would be, let's see, 6 would turn into 80, so 106. And there's my answer. So guess what? This angle right here has to have a measure of 106. That's it. Because what do we just prove? We just proved that those two have to add up to 180 degrees. So if we know one of them, we can find the other one really quick. We don't have to do any other work. You can do this a longer way by finding the arcs and going through the whole mess, but now that we know this fact, we are good.